Okay, today is Monday, July the 9th, and what we have here is connection diagram E2288, where we have a GOAB board going onto an MVTB2-1. It's actually a 2-2, but we're converted to a 2-1 because we have jumper JU1, so we can only fire one of the two inputs. That connection and on JU1 will fire the two SCRs at the same time. Basically a 2-2 we've converted into a 2-1, and here we have the two SCRs and anti-parallel, and we have our AC input and we have our AC output. In this particular case we have 480, but it can be anywhere all the way up to from 0 volts to 2.4 kV. We made, right now we have the power board with 24 volts AC, right? Both boards 24 volts AC, and based on the customer request, we're going to use a 15 volt signal to enable. So what we've done is, the way we have it on our oscilloscope, we have the blue channel is the AC input. We already have there an RMS value. So let's take a look at the RMS. On the AC on channel 1, we have 470 volts AC, and I'm going to do the same thing for channel 4. Okay. And of course we don't have anything, it's just marked here. And we have on resistor 8 on the GOAB board, we're looking at the enable signal. Right now it is configured for positive logic. The 15 volts, it's there, but it's the output, it's off, so we are not enabling, and we can see that the amber LED on either board are off, and we don't have any output. So let's go ahead and apply the 15 volts. And now that we've applied the 15 volts, we notice it was at 0. Now it's at 12 volts, the internal signal for R8, and we have an AC input and we have an AC output. Let me just see if I can change that trigger. There you go. So at this point we have 470 going in, 470 going out, and it's up. Let's go ahead and remove that, the 15 volts, and there it is. Once the signal comes down, we don't have an output. Let's try it one more time with a single shot. Okay, so go ahead and do that. Yeah, there you go. So we have an input. The AC is always on. The output is not there until the 15, and this is basically the time it charges for the power supply to give us the 15 volt, which translates into the 12 volts on the board at R8. And this is an output. And the same thing happens when we remove the. Okay, so hold on again. Let's try it out again now. And the same thing happens here. We have it. It's going there. Here's the 12 volts. Here again, based on the power supply, when this 12 volts is decaying, when the power supply is going out, then this disappears. Let's try it again. Go ahead and turn it on to it. Let me go. But this time we're going to use, go ahead, bring it in. This time we're going to use the switch. Okay, so 1 second. Alright, go ahead. So doing it with the switch, we don't count on the discharging of that power supply, and it's until this drops that we don't have an output. This is the end of this first video. On the second video, we're going to show the same thing, but we're going to use the negative logic. That is, the 4 will fire only when the 15 volts are removed, not when they are applied, and vice versa.